Hello everyone, welcome to your channel Data Science Studio, and today we are going to start with day 13 of Essential Python Programming for Data Science, and today we'll be having a session of NumPy part 2. So let's get started. So in today's session we'll be discussing some of the important functions of NumPy which we use in our data science and data analytics space. So first we'll import the library. The first method which we'll be using is load text method. So the NumPy load text module is actually used to read text or CSV files. So if you have, let's say that I have a CSV file which is a tips.csv, you can use your own data, and I can specify the delimiter which is a comma. So this is a comma separated file, and this delimiter can be anything. If it is text file, it can be tab or space. And here is one more parameter which is use columns equal to 0, 1, which means I am using the first two columns and I am skipping the first row, which means I am skipping the headers, otherwise it will throw me an error of string. It cannot convert a string to float. So make sure that your columns are numeric in nature, otherwise this will throw an error. And let's say I am trying to print the first 10 rows of the data. So here you can see that the class is NumPy ND array. The dimension is 2, which means since I have pulled 2 columns, it is a 2-dimensional array, and these are the 2 columns in the data set in the array format. Next method is the average method, and this is used to calculate the weighted average along a given axis. So if in the same example, let's say that I have this x which is my data, and I am calculating the average of x. So if I calculate the average of x, it will calculate the average of all data points. But if I want to calculate the average around the axis, so axis equal to 1 means if I want to calculate the average around the columns, I can specify axis equal to 1. And if I want to specify the axis along, if I want to calculate the average along the row, I can specify axis equal to 0. If I run this, I have axis equal to 1, which is the average at column level. So 16.99 plus 1.01 is actually your 9 point is the average, and then we can calculate at the row level as well. So if we calculate the average at row level, it is 19.78 and 2.99, which is nothing but all these rows, and this is the second row. Similarly, you can have the min and max function both at the column level or the row level or at the total level. So here I have created a matrix, and here I have the 4 by 5 matrix. So the minimum is 0, and if I do it along the column, it is 0, 5, 10 and 15. If I do it around the row, it is 0, 1, 2, 3, 4. So axis equal to 1 means along the columns it will find the maximum, and axis equal to 0 means along the rows it will find the minimum. Same thing we can do with the maximum as well. Like this we can do for maximum as well. And there is another function which is called as argsort. So this method actually returns array of indices of same shape as input array to sort the array. So this actually tells that what is the sequence of the number in terms of indexing based on the sort. So for example, 23 is at the second index, which means it is the second last bigger number, and then this 3 is 65. So which means 65 is the biggest number, and 0 is 15. So 15 is the lowest number. It is in the descending order. Now another important function which we use normally is linspace function. So if you want to generate evenly spaced values between two numbers, we can use linspace. So for example, let's say between 1 to 10 I have to generate 20 numbers, so I can use linspace. So here it will generate a evenly spaced numbers between 1 to 20. So this is also a very important method. And there is another important method which is called as concatenate. So it actually stacks your data along the row or along the column. So let's say I have two array, and first I am concatenating along the row. So when I am concatenating along the column, it will look like this, and when I am concatenating along the row, it will stack at the bottom, and when I am concatenating along the column, it will stack the right hand side. So you can see the difference. It is just stacking the arrays for the based on the column and row axis which you have provided. Similar method is a append method, and if you don't pass the axis in the append method, it will convert a 2D array into a flattened array, and in case if you provide the axis, it will just concatenate along the or append the data along the axis. You can see that. So here you can see that first we have created it has created a flattened array, because here I have not passed any axis. In the second, it appended along the column, and in the third, it appended along the row. So doing a similar kind of functionality with respect to the concatenate as well. And then we have where method. So where method is used very frequently. So where is used to filter elements based on the conditions which we have provided. So let's say that we have two array, we have a array 1, and I have to, and this where condition happens at item level. So for each item of the array, it will check if the number is greater than 40, it will replace it with 20, or else it will replace it with 40. So like this. So np.where array 1 is greater than 40, replace it with 20, or else keep it as 40. So wherever it is greater than 40, it is 20, or else it is 40. Now we have another functionality which is called as dot. So dot actually returns the dot product of two NumPy arrays. So let's say I have two arrays, which is a 2 by 2 matrix, and I am doing the dot multiplication. So dot is nothing but a matrix multiplication which we do in our mathematics. And another function to do the matrix multiplication is matmul. So matmul is also used to do the matrix multiplication. So if we run this, so here it will give the similar output. It is recommended that you use the matrix multiplication to perform the operation in the NumPy array. Another important module in Python is random module. So the random module contains functions for generating random numbers. So many a times we are working with generating the random numbers for our analysis. So let's say that I want to create a 3 by 4 matrix of the random number. So it will create like this, and all the numbers will be between 0 and 1 in the random method, and the numbers from and there is another function which is rand_n. So rand_n is nothing but, in this case, the numbers are drawn from standard normal distribution. So we have started a statistics class. So if you want to understand what is standard normal distribution, please watch my statistics classes as well. So when we want to draw the numbers from a standard normal distribution which has a standard deviation of 1 and a mean of 0, we go for rand_n. So here the data will be in bell curved shape in the random normal distribution. And then we have random.random method. It will again give the value between 0 and 1. And we have ranf method, which will give a float value between 0 and 1. Now if you want to have more than one value, a kind of array, you can go with random. You can pass a tuple like this and it will give a array of 6 elements. So in terms of the usage of these functionalities in data science, random function is very important because most of the time we play around with some of the codes or functionalities. We create a random array from the NumPy module and we perform various functionalities on that. And the where clause is also very important. The where method, which actually filter the elements of the array based on the condition provided. And in our next session we will be talking about some more of the NumPy functions which are used from the statistics point of view, and we will upload it shortly. So please subscribe, like and comment your channel and provide your valuable feedback in the comments, and stay tuned, stay connected. Thank you.